Hey guys, I hope you're all doing well. I want to show you how I was able to install EmuELEC on a Libre Potato single board computer with a 32GB eMMC module. I've read so many complaints about people having issues getting it to flash properly that it prompted me to make this tutorial. The method I use involves making a Fedora USB bootable drive. I'm going to use a 64GB Micro Center flash drive, but anything over 8GB should be fine. Head over to fedoraproject.org. Scroll down to the Fedora workstation block, then click the Download Now link. We want to download the Fedora Media Writer. I'm doing this on a Windows PC, so I'll grab the exe file and install it real quick. With the software installed, let's select an image source. I'm going to select one of the spins. I prefer Mate, so I'll be using that for my demonstration. Select the appropriate USB drive. When I run stuff like this, I disconnect any USB flash storage, anything external, except the one that I want to write to. It's up to you whether you want to delete the download after writing. I don't need it, so I'm just going to check the box, then click Download and Write. If you're certain you selected the correct drive, go ahead and click the Download and Write button. I'll speed this up to save on time, but the entire process took under 10 minutes. I'm going to exit the program and eject the bootable USB from my computer. Next, we want to boot from USB. Depending on the system will determine how this is accomplished. On my laptop, it's F12, but on my desktop, it's F8. Also, you might need to disable Secure Boot if it's enabled in the BIOS. Once booted into Fedora, connect to Wi-Fi or Ethernet, then open a terminal. You can either enter the commands manually, or open a browser, navigate to this video, copy and paste the commands from the description. In Fedora, you can paste into a terminal using Ctrl-Shift-V. I'll speed up this section, but it only took a couple minutes to complete. Now I'm going to run ls-usb to see which devices the computer sees. Then I'll plug the potato in while holding the Uboot button. It needs to be plugged into the upper left USB port closest to the Ethernet port. I'll run ls-usb again, and we can see it now detects the Amlogic board. If you don't see it, it's possible you have it plugged into the wrong port, or the Uboot button was not pressed in properly while inserting the USB into the computer. Once we see the Amlogic entry in ls-usb, we can run the command to mount the eMMC. The command will be listed in the description of this video as well. I'm going to open gparted to check that my computer can see the potato as a storage device. I'm using a 32GB eMMC module, which on my setup is at dev STC. I'll close out a gparted and open Etcher. Click where it says Flash from File. Go to the home directory, which is where the EmuELEC image file is saved. Click Change to change the target storage device. It is very important to only choose the eMMC storage, so I'll uncheck all the devices and only check Linux UMS Disk 0. Click the Flash button. I'll speed this part up, but it does take a few minutes to complete. At this point, we can close Etcher and disconnect the potato from the PC, then connect it to an HDMI monitor, connect the controller or keyboard up to it, and power it on. I'd recommend leaving the computer powered on if you need to add ROMs. We'll go into this part after the initial boot. The first boot will expand a partition, which will take a moment. Then it'll reboot, and on the first boot it takes a little longer to boot than it will on future boot ups. Now that I've booted into EmuELEC, we will configure the controller, then we'll add some ROMs. This can be done a couple different ways depending on whether or not it's connected to the internet, or if you want to directly connect the potato back into a computer again. Let's shut down and go over adding them via a computer. We're going to disconnect all the cables from the potato, then plug it back into the computer while holding the Uboot button again. Remember, you want to connect it to the upper left USB port on the potato. We'll rerun the last command, which can be found by pressing the up arrow on your keyboard inside the terminal. The potato will be mounted as storage and we can copy ROMs over. I'll copy over a couple Neo Geo ROMs from a USB flash drive to the eMMC. The folders are pre-made, so be sure to drop the ROMs in the appropriate folder. Once the ROMs are copied, we'll eject the potato and connect it back up to a monitor, controller, and power. We can now see Neo Geo as a selectable system. Let's go test out a game. It looks good to me. To exit a game, hold the hotkey and press start twice. Now we'll go over adding ROMs via the network. You'll need to connect to Wi-Fi or plug into a switch. Back at the computer, we can connect to the potato via IP address. I'll use the Fedora live session from earlier. I plug the flash drive with ROMs into my computer and I'll copy a Neo Geo Pocket Color game using Ctrl-C. Next, I'll press Ctrl-L to highlight the address bar. Then I'm going to type smb:// then the IP address of my potato. For the username, I'll enter EmuELEC, and for the password, Linux, all lowercase. I'll navigate to the ROMs folder. then the ngpc folder, then I'll press Ctrl V to paste the ROM. Back on the potato, we now have to run the update games list. We now have Neo Geo Pocket Color. I can now long press on the East button to scrape box art, gameplay video preview, images, and even game descriptions. I'll go ahead and test the game out to see how it works. After a few seconds, I see it's booted and I can listen to that sweet intro music. Let's jump into a quick match. If you made it this far, congratulations. I truly hope you enjoy playing your favorite retro games on the potato. It should handle anything up to the PlayStation 1, maybe even some Dreamcast games perfectly fine. I discovered this board a few years back when Raspberry Pi boards were way above MSRP, and I'm pleasantly surprised at how well it worked on various projects such as Pi-hole, Octoprint, and even as a media streamer. The board can also run Batocera and even Android. I had to install Android using Libre's USB burning tool, and I used a custom Android TV ROM. I'll leave links for everything in the description. It's a shame the cost of a single board computer keeps going up, this one included, but I'll use this as motivation to find and test lesser discussed boards, or even ones that offer a good value. Thanks for watching. I hope to chat with you in the comments section. Have a great day.